This is video 3 for section 7.4. In the last video, we saw an example where we had linear factors in the denominator. In one example, we had different linear factors. In the second, we had some of them were repeating. Now we will look at examples with quadratic factors in the denominator. So there are two types of cases here. In one case, we have that the quadratic factor is of this form, s squared plus a squared, which cannot be factored. And so how do we find the partial fraction decomposition for that type of problem? And then we can have a factor where we have as squared plus bs plus c kind of expression, quadratic expression. So note the difference is that in the first case there is no s term there, whereas in the second case we have an s term there. And we are looking at the case where this cannot be factored. The first one definitely cannot be factored, but the second one, in some cases it can be factored as, or it can be written as product of two linear factors. So but in this case, we are looking at examples where we cannot do that. So the first example is when we have the quadratic factor is of the form s squared plus a squared. This case is just similar to what you used to do in Calc 2. So on top of when we split as a partial fractions, the top factor or the expression on the top of the quadratic factor will be a usual or normal linear factor. So like mxs plus b or ms plus a or something. Because we are taking the uppercase letters here, so we just continue with the a, b, c, d, whatever. So we start by writing our factors like this, and then perform the usual procedure, multiply by the common denominator, and we get this equation 1 here. Now again doing the same thing that we did before. Let s is equal to -3. Why -3? Because it will make this term go away, or this term 0. So we plugging in s is equal to -3. The left hand side is this, and the right hand side, because the second term is gone, and with a I have s squared plus 5. So 9 plus 5, which is 14. And on the left we are getting 15. Because 27 plus 3, 30 minus 15 is 50. So we get a is equal to 15 over 14. Now I can keep picking values of s and plugging in, but what will happen, I will get set of equations, or system of equations. If you want, you can do that, but I would like to compare coefficients. So we have to expand the right hand side for that. So here is the expansion I did, and now I'm going to compare coefficients. So what coefficients are we comparing, or whose coefficients are we comparing? Well, this is what it is. We will compare the coefficients of the powers of our variable. What is the variable here? S. So we are comparing the coefficients on the left and the right of s squared, s, and 1. 1 is for the constant term. So for s squared, note here I am putting a colon. I am not putting an equal to sign over here. The colon is for the colon is just telling us for which coefficient we are looking at. So s squared. So on the left, the coefficient of s squared is 3. On the right, we have two terms which have s squared. So we get a plus b then so 3 is equal to a plus b, that is one equation. Then we compare the coefficient of s. On the left hand side we have 5 for s, and then on the right hand side the two terms with s are 3b plus c. So that gives me this equation number 3. And the last thing I compare is the constant terms on both sides. So the constant term on the left is 3, and so I have 3 here, and on the right hand side the constant term is 5a plus 3c. So I get equation number 4 there. Now we can already know the value of a, so from number 2 we can get the value of, from number 2 we can get the value of the b. So from 2, b is equal to 3 minus a, just plug in, I end up getting b is equal to 27 over 14. Now using theorem number 3, equation number 3 to find c, where we can either use number 3 or number 4. Both should give us the same answer. Once we found the values of a, b and c, we plug in and rewrite our transform. So here a over s plus 3, or 15 times over 14 times 1 over s plus 3, plus this is, so this was, remember, a, this was b, and this is c with the negative sign. So now I am going to split and write it, the second term as a sum of two terms. So the first one as it is, plus the second will be 27 over 4 times s over s squared plus 5. And the next term will be negative 9 over 14 times s1 over s squared plus 5. And now we can write our inverse transform. So f of t is equal to 15 over 14 e to the negative 3t plus 27 over 14 cosine of square root of 5t, because remember this thing, you have to look for what is the b here. This can be written as square root of 5 whole squared. That's why the b is square root of 5, which appears over here. Or the last term, so we need the square root of 5 up here, which requires that we put square root of 5 over here with the constant or the coefficient. So I end up getting 9 over 14 into square root of 5 sine of 5t. So this is the final answer.